Good morning, good afternoon, and good evening. Welcome to our webinar, Operational Best Practices in the Cloud. This is the fourth and final webinar of our four-part October series called I'm in the Cloud, Now What? Today's webinar focuses on how we automate and manage cloud servers at RightScale. To set the scene, we'll provide a brief overview of the RightScale architecture, and then we'll launch into a conversation of the best practices we follow to manage common operations scenarios such as the release cycle, monitoring alerts and escalations, and what we do when servers fail. However, before we get started, we'd like to ask you a few questions. So we're going to launch some polls now. Take a moment to answer this first question. So we'd like to know, are you using the cloud today? And we define the cloud as infrastructure as a service, so using Amazon EC2 or Rackspace. So select the one that applies best. The first option, yes, with one or more important projects means maybe you're running a couple applications in production in the cloud. The second option, maybe you have one app that is running in production. Third option, yes, beginning to explore, you're just starting to check out the cloud. Or fourth and final option, no, you are not currently running in the cloud at all. So leave this open for a few more seconds. And then we'll close the poll. Thanks for your answers and share the results. So it looks like over half of the audience, wow, I'm really impressed actually, over half of the audience has multiple apps in production in the cloud. So that's good to know, and the remainder of you guys are spread evenly between the other categories. We have two more questions for you. These are real simple. Second question is, so if you are using the cloud, are you using cloud management? So select the one that applies here. So yes, you're using cloud management from the cloud provider. So for instance, if you're using Amazon EC2, then you would be using the AWS console. Yes, you're using RightScale. Good job. Yes, but you're using another third party. That's okay too. No, you're not using cloud management, but you're checking it out, or just no, simply you're not using cloud and you're not using cloud management. Leave this open for a few more seconds. And another broad distribution here. So several of you are using the cloud provider's management tools or are on RightScale, so thumbs up to that 25% of you. And then there's another 30% that are just beginning to explore. So good to know. Thanks. Final question, and this is the easiest one, I promise. Just tell us what's your role. And this helps us understand who you guys are and if there are any particular points in the webinar that we maybe need to address in more detail. So are you in ops? Are you in development? Are you in IT? Maybe you're in some other technical role that wasn't covered by those previous three options. And then the fifth and final option is really to help us understand, are you more on the business side of things as opposed to technical side? So looks like we've gotten responses from most of you. So we'll close the poll, push out the answers. And okay, that makes sense. A large portion of the audience is in operations. It's perfect because this webinar is all about ops. Majority of you are in tech, and then about 20% are more on the business side of things. So if any of you guys have questions during this webinar, especially the business people, do not hesitate to ask. Let's close this poll now and get started with the webinar. So I would like to introduce our panel today. We're joined by Rafael H. Saveja. He's our VP of Engineering at RightScale. I also have here with me Giuseppe Blanquer. He's our Senior Systems Architect. So one thing, just on the subject of questions, again, that I'd like to point out about GoToWebinar is that I recommend you take a look at the GoToWebinar questions pane in the GoToWebinar control panel. So Dave Manriquez, our account manager, is standing by to answer any and all of your questions as they come in. And then also throughout the course of the webinar, Rafael and Giuseppe will address some of the more broadly applicable questions live on the air. So just make sure to ask your questions early and often. And with that, Giuseppe, I will hand it off to you.
Okay, well, thanks, Sarah. Let's get started. This is the agenda that we have for today. The overall overarching theme of today is basically to show how we, RightScale, manage our infrastructure as an example of a SaaS-based system that is fully basically running in the cloud. So we're going to take a look at how we manage the configuration of our architecture, how we manage our release cycle. We see how we going to put the monitoring in place and connect it to alerts and escalations. We're going to see some tips on how to think about when servers fail, and finally get a summary of the overall best practices of today. So let's start with the RightScale architecture. Before that, just a few fun facts about RightScale. We have we have launched about over 3 million servers up to date. We continuously monitor a lot of servers, over 100,000 servers every day, which really means that there's a fair amount of traffic going on into our architecture. Other fun facts is that we do about, we resize our arrays about 2,000 times a day. We trigger about 35,000 alert escalations based on your monitoring. We send 20,000 emails based on those escalations. There's a fair amount of close to 10 terabytes of monitoring data exchange within our servers every day, and a fair amount of logging data, like syslog type data, also sent into our infrastructure. Now, let's take a look at what RightScale is at 30,000 feet. Basically, what's happening in RightScale is that is a full SaaS application that runs in the cloud, and on top of it, we manage our RightScale infrastructure using RightScale, which means that we have at our fingertips every single of the things that we offer to you as a customer. So that's why we think it's a good example to give our best practices, because it's some things that you can actually do on your own. As far as our architecture, we have the basic pieces that any SaaS service would basically have. We have application servers, we have load balancers, SQL databases, NoSQL, and every single thing that you can think of related to that. So the way that we manage this architecture, which is really composed of hundreds of servers, has a very basic premise, which is what we call server templates. Server templates is the basis of configuration for each of the servers that we have in our infrastructure that allows you to configure and to specify what are the things that you want to have configured in your servers, what packages you want to install, how do you configure the file systems, how do you configure your applications, what versions of the apps that you want, etc., etc. So for the ones that are not used to or they don't know very well what a server template is, since it's such important in the way that we configure the servers, I have a quick slide, kind of a primer of server templates. And the best way to describe it is the following. From a cloud provider perspective, what people are expected or used to doing is to launch a server based off of a base image. A base image is nothing else of a burned copy of kind of a CD-ROM kind of thing, copy of everything that you want that server to have when it boots. It basically has all the file systems, all the configuration files, all the packages that you need in there. Now, if you have many different types of applications in your service, you may want to have to, take care of and have a lot of these images configured with all the permutations of the packages, the base operating systems, the configuration files that you want. So basically, if you have a lot of different subsystems, you end up having hundreds, even thousands of these bundled images. So the premise of a server template is different, and that it basically say we don't want to manage hundreds of these base images, which are very difficult to bundle and to manage. What we're going to do is have a very small set of images that have basic operating system installed with just a few tools, and express the configuration of the servers based on a set of scripts that are going to basically configure the server as it boots. So the premise of the server template is that you have a base cloud image or a base image that may even work for different clouds, and then a set of things that you can configure at boot time. So these scripts makes it very, very easy to debug and iterate, and you can version these templates, you can publish them, you can share them with other people, which makes it much, much easier to manage. Now, with that in mind, what we do to manage our infrastructure is make heavy use of these server templates. Our production deployment has about from 15 to 20 different server templates, and we're using the server templates that are available to you too. Some of them we use really off the shelf, like our MySQL templates. We use exactly the same template that we publish and any account can use. Some other templates we customize for our own purposes. Usually just means sprinkling some Ruby or Bash or Chef recipes within the template to configure, to install a few extra packages or to configure some files differently. And some of the templates we have built from scratch. For example, for our messaging, our RabbitMQ templates or the Cassandra templates. Another important piece of configuring the infrastructure is how to use deployments. And deployments are a concept that basically groups servers that are logically related. So this is a screenshot of our production account in which we see one deployment on each of these lines. So for example, the second line says the core USC's deployment. And in this deployment, for example, we have everything that is related to the dashboard, the services and our APIs that you actually use every day to manage your servers. So if you see underneath, we have the same, but in a different region, and we have a lot of servers configured but not running in case we want to, fail over for DR purposes. And then we have other deployments that, they have our global NoSQL databases. We have deployments that contain our monitoring servers for the different regions, etc. So the key here is that you want to segregate your different servers based on logical aspects of your application. And the good thing of putting all the similar servers within a deployment is that a deployment is a container of input configurations. So if you configure a given input for a deployment, every single server within that deployment is going to inherit that. So for example, we use that often to configure within a deployment what branch of the main application code you want to check out. You change it in one single set for that deployment, and every single server that you launch after that will inherit it. Okay, so kind of to wrap up this section, there are two main takeaways. Number one, make sure to use server templates. Do not boot servers based on raw images. It's going to get out of hand really, really quickly. Also, make sure that the server templates that you use are well configured in terms of multi-cloud images, these MCIs, because then will allow you to migrate from one cloud to another, even if it's within the same provider. If you have a good server template that has an MCI that supports all the Amazon regions, you can basically launch the same server in different regions really by just clicking a button. Okay? And the other takeaway point here is that think about the deployments and use them such that you can guarantee consistency across the servers within them. Right? Make sure that every set of servers that use the same set of inputs, put them in the same deployment, because then it's going to be much easier for you to manage. Also, have in mind that you can have deployments in which you have configured servers, even if they're not running, but that you can launch them at once for DR purposes. And then make use of the macros or even the API tools to automate this cloning of deployments and configure things, to even possibly stand up entire deployments within a click of a button. Okay.
Joseph, maybe before we go to the next section, I think there is a question that is relevant to what you just mentioned. The question is, why not process log data where it lives instead of shipping it to the RightScale servers? Example, process with MapReduce way. You want to answer that, or I can?
Yeah, we can. I mean, it's up to you what you want to do from that. It depends really on your application. The main I guess use case for having our syslog servers is that we want to have a way to aggregate logs for your servers that you can even browse and explore even after a server may have died. So depending on what your application, you may want to do some number crunching already in the different servers, but depending on some other applications, you just care about having a way for browsing the syslog data after the fact of a failure.
Yes. And another question, and I'm going to try to answer that, is how long does it usually take to start a server from a server template, from the time it begins launching until it is usable? Well, it really depends on the complexity of the server template. If your server template is doing very little configuration, then it's maybe some seconds after the infrastructure basically tells you that it's ready to be used. If the server template is much more complex, well, the time that it takes to do whatever actions you program in your server template. If you're going to go and bring some packages and do a very complex configuration, well, you have to pay for that time. What we have discovered is that the benefits of using server templates, the flexibility really outweighed the extra time that may be a couple of minutes or maybe more than that, maybe 5 minutes. We are never really concerned about that time if you really program to take into account that eventuality.
And I want to add a couple more things. There's a couple more there's a little more behind the server templates that we are actually covering today, but we have a lot of systems in place to mirror packages so that the installations go very fast. We have a way to mirror any attachments that you add to the server template so that things are very fast. You pull it from the closest region that you're putting servers, etc., etc. So there's a fair amount of an optimization behind the scenes that happens to optimize this boot time.
Thanks, Joseph.
Okay, so then let's get to the next section, which is about the release cycle. And the key here about the release cycle is that the main challenges of a release cycle is, in my mind, is knowing how can you provide your developers and testers and all the way up to production with the machines that they need to develop, test, or even run your application. So it's that they don't really need to know how to configure these machines. Developers only need to know how to change the code and test. They don't need to know how to configure. They don't need to be sysadmins, and all the way up to the production. So there's this flow cycle slide that I think makes a good case for how we internally at RightScale think about managing this release cycle. So let's start at the top, where one can think that of an architect of your product really cooking up this reference architecture. In this case, we're going to just take the example of a typical 3-tier architecture in which you have a couple of balancers for failure, an array of application servers, and then maybe just a master-slave database on the back end. So if the architect says these are the different pieces that you're going to actually end up running in production, the way we think about it from a RightScale perspective is that, well, your developers need to be able to somehow use this infrastructure. So your sysadmins can put together a server template that has some scripts that know how to configure your application server, say Rails or Java, if you're using it, and a database within one box. If you have that, the developers with one click can launch this and start testing their code. As soon as they have tested their feature and you start merging features downstream, you start getting into integration things. And in those integration things, you usually need more power, right? You need more machines a little closer to what you run in production. So in that case, your sysadmins can strip some of these scripts and have some templates that you can launch a load balancer. Maybe then you need a couple of individual app servers. And maybe you need only one database. Maybe you don't care about the slave database. So, and so on and so forth. So you can think of your sysadmins to be able to compose these scripts and reuse them into different templates, such that at the end of the day, what you're testing and staging is almost the same as what you have in production. Okay, so this is how we think about in terms of configuring our release cycle. So in particular, RightScale uses a different number of deployments. Every Scrum team that we have has its own mini environment. That means that every Scrum team has its own mini RightScale, if you will. So it has the same components of what RightScale provides, but in a much smaller setting, much more compressed. There's many features bundled within each of the servers that they have. We do have we have a couple of staging environments always set up that are much more close to what we have in production. Obviously not the number of servers, but in the number of pieces of the server templates that are launched. And we have a single production environment. So think about bringing this same configuration from a smaller sets of servers all the way up to the production environment. Another important aspect of these environments is thinking about accounts. We keep separate accounts for testing, staging, and production. That means that they are really the access to the clouds that we give to our developers is different from the access to the clouds that we give to our QA people, and obviously different from what we have in production. We have one single team of sysadmins, as I was saying before, manage all these environments. The sysadmins are the ones that are going to configure the same templates in testing, then staging, the same in production. Okay, so that's actually very important. As I said before, the main thing is to use the same set of scripts and server templates across all these different verticals or cycles. Use the accounts for getting security, but make sure that the templates and scripts that each of these accounts use are the same. Share them across the different accounts. Publish them to the marketplace if you want, but use the same. That way, you end up having almost the same configuration that you're testing in staging that you will have in production, right? Usually the only difference is the size of the machines that you actually spawn from these templates. Also have something in mind that the cloud provides, especially with something like RightScale. Just think of being able to set up full environments, even if it's just a couple, 20, 30 servers that you want to use for just a few hours to test some particular thing. Think of doing that. That's actually, the cloud is paid by the hour, so you should not feel weird if you want to do a big test that only takes a couple hours and, spawning up 50 servers just because you want a realistic test of whatever you're testing. Right? The cloud is cheap for these types of temporary environments. Okay, so a couple points getting at the end of this session. 3 main takeaways. Number 1, don't be afraid to run many environments. Cloning, especially in server templates, is very easy. Feel free to dynamically clone, launch, and tear down big environments for quick tests. Obviously, you need to have a fixed set of environment developments for your different developments or integration and staging and so forth. So you can have those more of a static sort of configuration. Use the different accounts to segregate users and configurations, especially security-wise. And think that sysadmins are expensive and cloud servers are cheap. So don't feel bad launching servers just for a quick use. The other important point is reuse the server templates so that your environments are consistent. Make sure that you're testing the same exact configurations across all of them. Right? Make use of the versioning. These server templates can be versioned. You can freeze software repositories to make sure that when you launch the servers with the same template, the exact same packages are pulled in. You don't want suddenly a different version of the package to sneak in into one server that you're booting today that wasn't there yesterday. Share and publish these templates across your accounts, and maybe even share them with other accounts. And if you want, you can group a certain amount of scripts or write scripts or chef recipes to create say an all-in-one, what we call it, server template that has a lot of the software within one server, because that's very useful for your developers. They don't care about the performance, they just want all the software installed in one single box. So think about that too. And then an important piece of managing all this is please avoid upgrading existing servers. Have a fail-forward mentality instead. If something does not work well, or if you're debugging a server template, do not try to go and log into the server and fix the scripts in there. Just fix it in the configuration of the template and relaunch the server. And if it's something because it has gone wrong in the server, leave it running so you can do a post-mortem later on. And even if nothing was wrong, you're just adding new features, leave it running so you can roll back. Right? And that's especially important for databases because you can think of launching additional slaves. You can freeze replication on slaves to have upgrade point-in-time recoveries. You can take snapshots and a lot of the things that you can actually not do with physical environments. And actually, I have one more slide in this section to show this. And this is a slide that probably will resonate with some of you, especially in the sysadmin arena, and how to do upgrades of the software of your application. So this is basically what we do on our release night. In this particular case, it's a simplified case, but it's a typical 3-tier architecture. You may have some front ends, you may have your application servers running right now, serving your customers, and that may be backed by a master-slave sort of pair of databases. So if you want to upgrade your application without, with the ability to be able to roll back if anything goes wrong, this is what we do. So the first thing that we do is boot up a new set of servers that run the new code. We keep these servers completely disconnected from the front ends or the database. We just have new running servers that have the latest bits that we want to basically release that night. Okay. Once we have that, we're going to get ready and have a second slave for extra backup recovery, and we'll see why. So once we have a second slave up and running and all caught up with the master, we're ready to start the release procedure. So what we do in that case is we cut access to the site. That's the moment in which the maintenance page goes up. We cut every access from the front ends, we then make sure that nobody is writing to our databases. Once we make sure of that, we stop replication on that second slave. So we have a hot database machine with the exact same configuration at the moment of the maintenance page. For extra security, we always take an extra snapshot directly from the master. And once that is done, we can start upgrading the database schema. Once the database schema is upgraded, then we can allow the new code to start using that database. We can do some internal testing to see that everything works well. And once we're happy that everything works well, we open up the site to everybody else. So the interesting thing here, note that at this particular moment, we can always roll back to the exact same code and data that we have, because we have a second slave hot and ready to go. We have a snapshot if we want to restore it, and we can really quickly re-enable the old servers with the old code. So that hopefully that gives a bit of visibility of some of the things that the cloud allows you to do with something like RightScale on top that was kind of impossible or very, very difficult to be done with normal on-premises infrastructures.
Okay, thanks, Joseph. Maybe we can answer a couple of questions. This one is for you. It's how can the RightScale product be used to set up, monitor, migrate, move servers using multi-cloud server templates between two different cloud vendors?
Well, the idea behind the multi-cloud server templates is that they're based off what we call the multi-cloud images, which you can think of a definition of what a basic image has, but with mappings to specific images for each of the clouds that it supports. So one multi-cloud image that is CentOS 5.4 that has our right-link agent will map to particular cloud images for the different clouds that supports. So if everything that the template has or depends on in terms of configuration, if it only assumes that the basic software of the multi-cloud image has to be in place, then you can really relaunch that to any of the clouds that are supported. Obviously, if your configuration has particular things that rely on cloud features, then you cannot really move these things across. But all the templates that we actually have published basically support all the clouds, all the underlying clouds that the MCIs support.
And I think you answered the second question, that was, will MCI work for EC2 all regions and Cloud.com and Rackspace? And well, he added Microsoft and vClouds. I think the answer is yes, in principle. That doesn't mean that right now we can provide MCIs for example, the vCloud. But at this moment, our MCIs, multi-cloud images, work for all the regions in EC2 and also for Eucalyptus clouds and for Cloud.com clouds and for Rackspace. And we're actively working to add more clouds as we speak. So I think the answer is yes, in that respect. So let's move on, and now we're going to talk about monitoring, alerts, and escalation. This is a very important section, and in order to do, in order to really be proficient in production, you have to depend on putting and monitor as much as you can, connect all these monitoring data into alerts, because they allow you to diagnose and optimize your service. We make a lot of use of off-the-shelf monitoring. In fact, we use CollectD. It's something that is very popular in the field, and we use it to monitor the operating system. These are the basic metrics, for example, the CPU values, the disk activity, the memory consumption, also the network activity or the processes and the system as a whole. I think these metrics is what normally you get when in Linux or in a Windows server, and I think these are well known. In addition, we also have plugins for these monitoring systems so that we can monitor specific applications. Some of these applications are open source, so they already have open source and plugins in CollectD. For example, are Apache or MySQL or Nginx or even the SQL Server from Microsoft. So most probably your application consists of most of these subsystems, so it's easy for you to connect them to the monitoring system and start receiving the statistics. In addition, there are many more CollectD plugins. or you can write your own. And we're gonna talk a little bit about that. So in addition to using off-the-shelf monitoring, it's important that you know how to construct and to build custom monitoring. I'm gonna give you some pointers we provide in the support website of RightScale, a lot of documentation on how to do this. We're going to also mention a little bit about specialized graphs that we have built and provide in our dashboard that allows you to manage on the large. Large applications, successful applications, they don't consist of maybe 10 servers, but they consist of hundreds, even thousands of servers. So monitoring them, receiving alerts, and keeping the health of the system in check is not trivial. So the right tools have to be used in these situations. And we're also going to tell you how do we use alerts and escalations. So why don't we start just about monitoring. Well, I think these graphs that you are seeing at the bottom, and let me just highlight them, represent two set of servers that consist of the dashboard that most of you will interact. And one is on the right is the dashboard network activity. And as you can see, it's important to understand the patterns of activity and to monitor these on a daily basis, because it tells you, well, how your servers are behaving. It shows here the aggregate contribution of eight different core servers, application servers, the dashboard. And it shows, well, the normal activity that you will expect, that is during the weekdays. During the weekdays is where most activity happens. And this follows the actual working hours, probably starting at maybe 7 a.m. on the east and ending maybe 5 or 6 p.m. on the west. And then during the night, there is less activity. So once you understand this behavior, you can plan, for example, your autoscaling so that you can put more servers during working hours and maybe shut down some servers during the night, or in addition, during your Saturdays and Sundays, if you really want to go and be more aggressive in terms of saving money, you can try to exploit that fact. Now, as you can see, the API network activity is very different. And the reason is that the API normally is accessed through programs or scripts that are running 24/7. So you don't see the patterns of human activity that happens. It's basically active the whole, every day and constant during the day. So it's important that you monitor as much relevant data as possible and that you display it in insightful ways so that you can understand how is the behavior of application, and also that you can learn what are the abnormal regimes so that you can install alerts so that you are notified when things that are outside of the normal behavior happened. So we do that. We put a lot of alerts, and we proactively try to eliminate all the conditions that raise critical alerts. The idea here is that once you manage hundreds of servers, you cannot be interrupted every 5 or maybe every hour because the system is basically working in a normal state. You have to be proactive in resolving these issues, so as you continue to scale, the work that your system administrations have to do is scaled also as well. Now, we make an example of all-the-shelf plugins for collecting statistics. There are many of them, and one that we use extensively is MySQL. This slide is only to show you the wealth of information that this plugin provides, going from aggregates contribution of how the different operations on the database are executed. For example, how many inserts versus how many updates versus how many selects. And also going deeper into the actual select, how is the behavior of these different queries into the database? Are you doing too many scans of the whole table, and therefore you have to load a lot of records into the memory of the database? If you do that, probably the working set of your application is not going to fit in the database, and you're going to start paying salt this time. And as you all know, once you are reading from the disk more than a minimum amount, the performance of your application suffers substantially. You can also follow specific commands so you can learn, especially when you do an upgrade of your application, how the changes that you just have made affect the performance of your system. You can also look at the behavior of threads, the data that you are transmitting outside or inside of your actual database. So this information is very important, and every server that you launch through RightScale using our server templates already install all these monitoring systems, and particular to the actual server that you're using so that this information is available to you. This is just an example of going deeper into one of the graphs that we display prominently in a very big in our dashboard, because it allows to tell us whether the behavioral database is the way we expect it. We want the blue line that represents table scans to be as low as possible, and as we scale the application and we make changes, we monitor these regularly. If we see that somehow this blue line goes above the certain threshold, we start investigating, because probably what it means is that we introduce a query that is not making use of indices, or that we need to add an index to our database. So this information is very important. Now, unfortunately, if you write your own application and if you start combining these in very interesting ways, probably there's not going to be a plugin that is specific to what you need to measure. So you always have to start writing your own custom collect D plugins. And it's very, very easy. Any statistic that you can think of can easily be added as a monitor. All of these information, once they are sent to our servers and they are basically stored in them, you can graph it, and you can also connect alerts. So it's a very easy way. We do all the difficult work for you, so it's very easy to connect these alerts and also to put escalations that will respond to anything that will happen on those systems. Writing one of these custom plugins takes less than an hour. It's as easy as printing a line of formatted numbers every few seconds. And if you go to the support RightScale.com, you will see a lot of information. And let me just show you that. So that, let me go here. This is our support website. It's just support@RightScale.com. And if you go to the search, you can say custom collect D plugin. Search for it, and you will see a lot of documentation that we provide. And specifically here is an example of how to create a custom plugin for Linux. And we show you a complete example of how it's done, how to connect it, and all the steps that you need to do in order to add the new plugin to collect D. So we encourage you to use these pages, and it's very easy if you haven't done it before. Okay, so how we do it? We use a lot of Ruby to write these custom monitors. In some subsystems, for example, Cassandra, we use already open source packages like jcollectd that allow us to put data monitoring from Java Beans. So this is a well-known way of doing collecting statistics from applications that run on Java Beans. And in other cases from Passenger, we have a Ruby script that just parses the data that is provided by the command line interface of the application. Moving forward, this is just an example of the Cassandra that we actually use. We are basically very excited about using Cassandra, and we're starting to deploy it in many different services. And here, as you can see, we have some specific plugins, one that looks at the activity on Cassandra, and in particular, that's what we're showing, the activity, basically the reads per second. And the reads per second tell us whether the ring is overloaded or not. So it's one of the first indications that if something goes above a certain threshold, then we have to basically investigate and resolve these either by escalating or by adding more nodes to the ring. In addition, we also have a plugin for the JVM, the behavior of JVM for Cassandra, and also a macro statistics about the different processes. So now let me move about how you can monitor. Well, in the previous examples, like here, you just monitor one server at a time. And this is very convenient, but once you have hundreds of servers, this becomes basically unmanageable. So the question is, how can you monitor hundreds of servers? Well, we provide two different classes of graphs. One that we call stack graphs that allows you to display the contribution of hundreds of servers in a single graph and to distinguish the contribution of each of them. But what's important is to see the aggregate behavior. As you can see here, just an example, something happened on the morning on Wednesday in this graph that clearly shows that the load increased dramatically, that the number of servers in this particular graph increased from maybe 10% of that. It's very difficult when you monitor individual servers to see that kind of behavior. So the stack graph is very useful in those situations. in the one on the right top, that shows you that the same set of servers, but then how each of them is affected by this change that happened in the morning of Wednesday. And what you can see is that most of the servers were basically behaving normally, except for maybe a subset of 6 or 8 servers that somehow they became overloaded. And it's easy to find these patterns and to focus and for sysadmin to really work on what it needs to be addressed. And that's something that is very relevant once you are in the hundreds of servers for your application. So please, if you are using RightScale, we encourage you to start looking at these graphs and to use them extensively, because you're going to see that your life becomes much easier. Now, once you have detected anomalies, what to do with them? And we encourage to have automated actions by using alerts taken from the monitors. And the good thing is that you can create alerts for any monitoring, even for the custom ones. So it's very easy for you to be notified when something is out of whack in your application. It's important that you break your alerts into different classes depending on how you're going to respond to them. 2 simple examples is having critical alerts that need to be responded immediately. Another one will be to have just warning alerts that keep you informed that something maybe it's abnormal, but that they don't have to be addressed immediately. Maybe you want to do it during office hours. Now, your alerts can be trigger actions, what we call escalations, and these actions can be either sending an email to a system administrator to respond to the anomaly, maybe to run a run script that will fix the problem. Maybe the run script is going to reconfigure some parameters on the application so that the bad behavior is removed. Or maybe you want to scale a server array so you can add more servers to your service, or you can relaunch if the server goes wrong, basically is bad. You can relaunch a new server, or you can reboot it if you want. I think Joseph mentioned that we really encourage not to making changes to a server itself, but to relaunch a new one. So we give you the tools to do that. Now, we also integrate with third-party services like PagerDuty if you want to connect these so that your system administrators can respond and you have a hierarchy of escalations so that someone is always on duty and can act. So best practices, just a summary is make sure that you monitor your critical processes by using off-the-shelf plugins and packages. It's important that you don't spend much time just monitoring your servers. We provide a tool so it's very easy for you to do that. Use MOM process, for example, to monitor different the Ruby processes or anything that is running on the machine. Make sure that you customize your application to your application needs. Something that should not be a deterrent is to say it would be nice to monitor this metric, but we don't know how to do it. I think that that's not an excuse. It's very easy to do it, and it's something that is just the life cycle of any sysadmin person. And obviously, something that is obvious, plan out your critical alerts. Make sure that you have a response plan, and there is always a run book that tells you how to respond to these situations.
I think we have a couple of quick questions. One that you almost answered in this last slide is there's a question that says, can I set up an autoscale function when my application is dependent on the server sessions, which is busy most of the time, and we want to scale it dynamically? So with a custom plugin, like Rafael was saying, you could achieve that. You just have to monitor your sessions somehow to provide this graph, this metric to collect D, and then you can put an alert over this metric to whatever thresholds you feel comfortable with. So yes.
Yes, and these alerts on these escalation metrics, they don't have to be connected to the app servers themselves. You can monitor other servers in your deployment, for example, the front ends. So if you can take some metrics and from the front ends themselves and make then a decision whether to scale or not based on that. Normally, it's difficult to do that because the front ends don't really are the ones that are carrying the burden. It's better to monitor the application servers, but that's doable.
So there's another question that I think that is probably good to answer. There's a question that says, if we have a private cloud, do we need to set up a secure connection to RightScale so that we enable remote monitoring over SNMP in between RightScale and servers in our private cloud? Or is Collect D installed locally inside our private cloud? Well, the architecture of Collect D is one such that you have the clients installed, so basically the agent, if you think about it, installed in your running servers, and they send things to a central server, well, central in quotes. So basically the traffic is from your servers out of your cloud. So you don't need to set up any secure connection. You could do things like route all these Collect D packets through your proxy if you want to somehow have more visibility, but these packets are going to come out of your infrastructure into the RightScale servers.
Okay. So let's, I think we're starting to run out of time, so I'm going to start going a little bit faster. So this section is when servers fail. And the first thing is how to think about server failure in the cloud. And the first thing is you have to assume that servers are going to fail. That's just a fact of life. And in the cloud doesn't make it different from basically hosting in your own premises. So you have to design for failure. And that's basically the key thing to success. Make sure that your application, when it fails, remains healthy after a failure of a node. What it means is that you have to design in a way that there are no dependencies that suddenly when a node fails, the information on that node is critical in order to recover. If you do that, it's going to be very difficult for you to do that. For example, don't use sticky sessions, because in a way that will prevent you from moving to a new server or adding or removing servers. Make sure also that you distribute your application services so that if you have multiple services and if one node fails, they may affect maybe the performance of one of the services, but they will not affect the whole behavior of the whole system. What you want is that maybe one of these systems is going to be a little bit overloaded, but that the other services that your system provide continue to operate perfectly. And it's also very easy to fix, to scale, once you have these isolated services that they work together to provide the whole application for your customers. I think Joseph mentioned this at the beginning, and I'm going to repeat it again. Always debug your server templates, not your servers. That doesn't mean that if you have a problem and you have to do a fix in order to put your system back in place, you do it, but always make sure that you go back to your server template, go back to your scripts, and make the changes so that the next time that you have to launch that server, the configuration is going to be exactly as you want. The worst time for you to discover that you forgot to propagate something to your server template is when you are in the middle of a crisis. And believe me, the crisis will happen. They happen every day. Now, use alerts to reboot and to relaunch so that you can respond fast to failures. And autoscaling is something that is one of the great things about the cloud. You always know that there is a server available for you, so it doesn't matter how big is the load, how big is the change from what you were seeing yesterday to what you're seeing today. You can always fast respond to that behavior. And another point to send across is use dynamic DNS and static IPs for load balancers. What you want is that these new servers who are basically launched, they can find your front ends and your databases so that they know where to look. And it's important, and the use of dynamic DNS and static IPs is key for this. So let me just focus, because we don't have much time, about database failure. And here it's a little bit like apple pie. There's things that every sysadmin should know. That is, you have to do backups continuously in order to do rollbacks and disaster recovery. You have to also make sure that you can restore from the backups in event of a complete system failure. We have seen examples of some users that they are very, very conscientious about producing backups, but they never test that their backups are basically correct. And the worst time for you to find out that your backups are corrupted is when your master basically fails. And we provide one-click backup systems in our fully automated RightScale database managers. If you use these server templates, you will find that all these normal operations that you have to do with the databases, there are easy write scripts that you can execute. Now, you have to use database redundancy for high availability. For an example is just a master slave. And you always should be able to promote your slave if the master fails. If your system has a large database on the gigabytes and even more than that, you may find that once you promote a slave, it takes quite a long time for the working set to be loaded on the memory. So it's important that you try to prime your slave database so that the failover is done quicker. We do that so that we have a slave that is continuously primed, so that it doesn't matter when it's going to go into become a master, the time of recovery is going to be fast. Also, after promotion is complete, you have to be quick to launch a new slave. The probability of your master, of your new master failing immediately after being promoted is low, but it's not zero. So you have to be ready as soon as possible with a new slave if you don't have already one in place. I already mentioned that is worry about troubleshooting when you have the time. Don't do the troubleshooting when you're in the middle of a crisis. Just promote your slave if you know that your master is not going to be recoverable. So how do you take backups? Well, you can have the option to do backups to block volumes or to object stores. Examples of block volumes on the AWS ecosystem is EBS snapshots. Basically, you snapshot your EBS volume. The positive things about these is they're easy to snapshot, they're easy to rotate, it's easy to get a consistent snapshot of the state, and it's an instant restore. The moment that you mount the volume, the data is available in complete form. The drawbacks is they're difficult to move between clouds and regions. So at this point, the volumes that you have in a particular region, it's not easy how to move it to another in case you have to do, for example, disaster recovery. So you have to do some extra work in order to solve that problem. And you also have to back up an entire volume, and sometimes that takes time. So object stores, basically it's another alternative. S3 or cloud files in Rackspace is an example. And the plus things about this is that it allows you to do backups in other clouds. So, for example, for disaster recovery, it's important that you have a backup that it's on an object store, so that you can, if you have to do and move it to a different cloud, you can take the backup from there, the snapshot. Now, it allows you also to do backups of individual folders or files. So that means that you have the ability to do incremental backups, and that's also sometimes that's convenient. The drawbacks is you have to do more coding and more customization. You also have to worry about doing a custom rotation strategy, how to keep the different snapshots in place, how to organize them, and once you take backups maybe every hour, the number of backups that you accumulate can be huge. And finally is the download time that it takes to basically download the information. However, we use both object stores and block volumes in our systems for different purposes. Now, finally, best practices. Planning for failure. So no excuse for not backing your server. That's an obvious one. You have to have a plan for your rotation policy. And if you use our database managers, we help you by giving you parameters that allows you to tell you the daily, weekly, and monthly backups. Also make sure that you can back up across clouds and regions so that you can always have a plan for disaster recovery. And our database manager for MySQL and now for the SQL server allows you to do backups to S3 or cloud files from AWS, CloudStack, Eucalyptus, and Rackspace. And we will add in more clouds as we move forward. And you have to organize your backups. And finally, and very important, make sure that you test your backups, because it's easy to do it on the cloud, and the crisis is the worst time to find that these are corrupted.
Okay, so then let's do one more slide of overall summary of these best practices, and then we'll take a couple more questions that are in the pipeline. So let's see if this summarizes everything, captures everything that we summarized before. One important thing is keep your environments organized and consistent. As we said, think about the different accounts to segregate security for the different credentials. Put your servers into the right deployment so you can consistently manage these servers that are logically related. Use the same server templates across all your release cycles, and make use of macros or API calls to automate any of these processes. Change and debug configurations, not servers. Do not go servers, fix them manually, and then forget about it. Because when you want to launch the server, you want to have every single change that you did in place. So for that, use the server templates and the scripts within them. Make sure that the multi-cloud images that you're using in the server templates will allow you to launch the same server in different clouds. And always think in this fail-forward mentality. Obviously, think about how to monitor your servers and how to do it efficiently. Think of the different metrics that you need to keep track. And if they're not supported with the off-the-shelf plugins that we have, build your own. And make sure that you connect these alerts, this monitoring into the right alerts and do the right actions when certain thresholds are crossed. Automate everything. We could not stress that enough. Automate absolutely everything. You don't want to depend on any manual intervention at any part of your infrastructure. Use server arrays if you need app servers that need to scale up and down depending on the time of the day or the traffic. Use the macros or the full-fledged API that we provide to do complex flows for your deployments. Make sure that if you need something to be executed immediately, connect that to an alert and make that happen. Execute a script, for example. And last but not least, back up your databases. That doesn't only mean to just have snapshots or copies of files. Just be sure that you organize this, that you know the lineages of the backups that you're taking. If you're taking backups of striped disks, make sure you know that those are the disks that that conform into one single stripe configuration and what order you need to put them together to restore. Make sure that if you need multi-cloud backups, you do it that way. Rotate your configurations, keep your dailies, your monthlies in place. And last but not least, test them. Once in a while, get the backups that you have, restore them to make sure that you actually are storing something that you can use later on. All these points of backing up your databases become very, very easy if you use our off-the-shelf server templates. So I think that we have not much time to answer a couple more questions.
But I think we have an interesting question, so why don't we dive? The first question is, can a multi-cloud image be used for a private cloud as well? And the answer is yes. I think we put a lot of thought about designing the multi-cloud image, and there are very tricky problems, especially when you have a private cloud. For example, you may have a private cloud for cloud.com, and we may have an image, but the question is, well, how do we make sure that once you create your own image, and you put it on your private cloud, that our servers are going to be able to locate it and to use it? And I don't know if you want to add more, because
I think that it could be a longer explanation, but the main idea, the main takeaway is that a multi-cloud image maintains a mapping to particular cloud images, so you can either do two things: clone the multi-cloud image and add your mapping to point to the image that you want to be used, or use some fingerprinting capabilities if the cloud allows you to, basically, that allows you to locate the right image that you want.
Mm-hmm. Another question is, large virtual servers, many CPUs, lots of memory, with many applications aren't cheap to keep running inside public cloud nor inside private cloud resources. In order to comply with server templates, must we store all possible servers OSS images along with tailored application packages on local storage inside our private cloud? I think that there is a different answers depending on where you're talking about images or where you're talking about server templates. In terms of images, yes, you have to have the images inside your cloud, your private cloud. In terms of server templates, the answer is no. You use RightScale to download the server templates and that information. Also, for example, the high-level information that defines what a multi-cloud image is, that allows the system to find your own image, that also resides in our system. So you don't have to keep it in the private cloud.
Also, I would add something very quickly, that think that when you're using the server templates, you won't have a large number of cloud images on your site. you'll have a few base cloud images that the templates rely on, but you won't have, maybe you'll have 4 or 5. You don't need an image for every different configuration of the server template that you need, right? Remember that you start with a base image that has the basic operating system. Everything else is built on top. So the amount of storage that you need is actually quite low.
Okay, then we have why not monitoring for Oracle DB? That's a good question. There is no reason why not. We basically have addressed the markets that have been the most interesting for us, and that have been MySQL and SQL. We also have expanded to Postgres, and we have done less work on Oracle, but there is nothing in principle that would prevent someone from monitoring an Oracle database and to connect it to our system.
There may even be a CollectDB plugin that works for Oracle, for all I know. I don't know. Should we take the last question?
Yeah, let's take a last question.
Okay, so the question says, you appear, this is more of a high-level question. It said, you appear to provide server templates, monitoring, graph templates, and a front-end website to access our cloud resources. Please elaborate on security in between RightScale and private company. RightScale is perceived as a service and or coaching business, but do you also provide images, packages, etc.? Well, so the main architecture of RightScale is that you will have your own servers spawning VMs in your cloud. The images that you're going to launch will contain a little agent, RightScale agent, that allows it securely to contact back to RightScale and start asking for the different configurations that need to be run on boot. Okay, so you have a little agent that contacts out into the RightScale infrastructure. That's what happens at runtime. On the other end, you have a full dashboard as a web service that allows you to configure all these things and start and stop and interact basically with services within your cloud. So from that path, you actually have RightScale contacting your cloud controller to do the actions within your cloud. So you have the two paths, one from RightScale dashboard doing actions directly into your VMs, and then the other path, which is the VMs coming up and spawning up an agent within that VM that contacts back to RightScale and asks for things to do, so to speak. So I guess that to talk about the security, it's a little more, it takes a little more time, but basically all communication with inside and outside your cloud is securely encrypted and not visible to anybody else. And there's some whitelisting capabilities and some proxying capabilities that one can put on top of it in certificates if you require more.
And I think that's it.
Okay, cool. Thanks again, everyone, for attending. I just want to throw out this final slide with some contact information and info on next steps. When you exit the webinar today, if you could do me a favor and take 1 minute just to fill out our exit survey. We just have 1 or 2 questions for you at the end just to get your feedback on today's webinar and what you thought. I'd like to point out also that today's webinar was recorded, so we'll be sending out the archive link to that later tomorrow morning. Also, if you're going to be in the Bay Area in 2 weeks, the beginning of November, we're hosting our next RightScale conference alongside the Cloud Expo up in Santa Clara on November 9th. So check out rightscale.com/conference for more information about that. We'll also have some trainings before and after the conference that are very highly anticipated, and I'm not exaggerating. So yeah, check that out. We'll send out the webinar archives. There's some links here. Contact RightScale links as well. So other than that, thank you so much for your time today, and have a great rest of your week. Bye.